Problem 5-15. Last problem of the assignment. Here we go. Let's get it done. The angle of elevation of the sun, says the angle the rays of sunlight make with the flat ground, at 10 o'clock a.m. is 29 degrees. At that point, a tree's shadow is 32 feet long. How tall is the tree? So I kind of started out here. I got my little tree drawn. You don't have to do all this. I don't know. I probably wasted time, but I like to do that. So I got my tree here that's casting a shadow this way, and it told us that our shadow was 32 feet long. So let's go ahead and call that 32 feet. Now, if the shadow's on this side of the tree, that means that the source of the light, or the sun over here, is going to be somewhere on the left side. So let's take that and let's kind of draw in. Choose a line tool here. Alright, so this would be like the end of our shadow, and so we're kind of coming up at this angle right here. Our sun would have been somewhere up here. You can make it all nice and purty if you want to do that. Yeah, that's not really the best sun, but whatever. Deal with it. Now, so it's doing this. It says this angle it's making with the flat ground here is going to be 29 degrees. So what we have formed here is pretty much like a right triangle. We've got this tree here, and this would create our right angle. And we're trying to figure out how tall this tree is. So this tree makes up one leg of our triangle here. So we could just say, okay, that's going to be x. It's the height from the top of the tree to the bottom. So if we just kind of sketch that more as a triangle here, a right triangle, we've got a triangle that looks kind of like this. Sorry about the non-straight lines. We've got 29 degrees. We know that this side is 32 feet. This would be our right angle, and we don't know what this is, but we need to find it. So this is just a little bit of trigonometry. We've got this angle. We don't know the side that's opposite it, but we do know the adjacent side. So which trig function uses the opposite and adjacent sides? Well, that would be the tangent function. We know tangent of theta is equal to the ratio of the opposite over the adjacent. So how are we going to use this? Well, let's use the information that we have. We know that this angle down here is going to be 29 degrees, so we have the tangent of 29 degrees should equal the length of the opposite side, which we're calling x, over 32. This one becomes easy to solve here. If we know the tangent of 29 degrees is equal to x divided by 32, let's just go ahead and use the inverse operation and multiply both sides times 32. So what we're left with here right now is 32 times the tangent of 29 degrees should equal x. So I'm going to grab out my calculator here, make that a little bit easier to do. So let's do, first of all, need to check your mode. You see on these color editions, it tells you what mode you're in. I'm looking at degrees here. If you're not in degrees, you want to make sure you go to mode. And you want to look at the line that says radians or degrees. We currently want degrees highlighted. We'll get to radians later in the year, but right now we want degrees highlighted there. So then second mode, quit out. And to find the value of x, I'm simply going to multiply 32 times the tangent of 29 degrees. And we end up with about 17.74. That's approximately what x is. And remember, what we're looking for is x, and that's going to be in feet. So the height of that tree should be about 17.74 feet. So how tall is the tree? The tree is about 17.74 feet. We just used what we know from geometry. We used that trigonometry knowledge where we had our angle, we had the side that was opposite our angle, and the side that was adjacent to our angle. So the tangent. If you have questions, make sure you ask your teacher or seek help from somebody else. This is problem 5-15. This is Mr. Boyd signing off.